And we're back with demo time. Got kind of a test app, demo app, and a bit of the start of some debug tooling to go along with this Vecto communication library I've been working on. So here up at the top, this is kind of just a little demonstration VI, maybe not that little. Uh, got a fair bit going on, but it exercises programmatically generating config for a Vecto application, getting things running, setting up one group of data to publish, and it's just got 6 values. So setting that up in the current value table mechanism, registering it to be a published group, and then kicking everything off. Assuming all of that succeeds, we then go into a loop where we use the discovery service and the Vecto service to get the local system info, as well as um, get all of the nodes that are being discovered by the discovery service. So part of Vecto is auto discovery between the applications. The primary intent is that applications are pre-configured ahead of time, but this allows um, more dynamic IP addressing. Uh, so while different applications will have pre-assigned node IDs, which we can see in the front panel here, I'm putting in a node ID and a node name and some networking information. Um, it can dynamically adjust to some of the configurability of the networking after the fact, and then just updating the group values from this set of 6 sliders. This actually isn't working right now. I got to finish up some stuff with this, and then getting those values published out on the network. And then when the user stops, stop and clean up and shut down. And this all waits until you click the start button to give me a chance to tweak some of this information. Because I'm not going to be running this from source. I have an executable that I'm going to run, and I'm going to run the first one as is. We can see that it discovers itself. And for some of the connection types, starting to get some counts available. Eventually, there'll be UDP publishing information listed in here, as well as TCP command servers. We can see with the discovery service that it did find itself. Um, so, hooray. But let's get another one running. I do have this set to allow multiple instances. So I should get a second one, maybe. I would if I spelled it correctly. Nope. The executable there. Slick. Okay, so now I've got a second one. We'll do this as ID2 and beta. Um, we're gonna need a different HTTP port because this one's taken there. Gonna bind all the same stuff. We can publish the values in this second app to the same multicast address. All of the apps, we want them using the same discovery multicast address. But let's go ahead and start this. And we can see the first app already saw the second app because the second app starts advertising itself immediately. Um, and then after that, they advertise once every 5 seconds. So now there's 2 systems running. So we can see both nodes and the different names that are both part of the same system and the same cluster. Both have HTTP servers running. And all of this information here is available in the auto discovery mechanism. Now, one of the things that's going to be critical to checking, verifying configuration and making sure networking is configured correctly and data is flying around correctly is debugging tooling. And debugging tooling does not, ideally, it doesn't get configured for a specific system, and a developer can use it to debug any deployed system, or system in development in a lab or something like that. So I'm going to run this. Now, similar to these guys, I got to update some information, hit start. With this one, tell it what system we care about, what cluster we care about. A system is kind of an entire test system, so like a single test cell or a single test stand. And then a cluster is the collection of applications that directly communicate with each other. Um, you may have different parts of a test system that don't talk directly to each other. Maybe there's separate test cells, and there's going to be the ability to do some funky bridging and sharing some resources across clusters. But by and large, the intent is that you identify a system and then the groups of applications that talk to each other. So discovery address, one of the prime prime design choices in Vecto is it doesn't have any hard coded configuration schemes, so everything does need to be configured, which a little bit more effort on the configuration side, but it won't run afoul of collisions with any other reserved ports on a system. Um, Once you get a system set up and deployed and figure out what your networking configuration is going to be, you can set those as defaults in whatever you make for configuration tooling. Vecto also does not do any configuration file management. The whole idea is that the application layer does its configuration management and then pushes whatever information it needs to into a couple of config objects, like we can see here, setting some properties for the things that we want run, setting up the current value table groups that are known about. But yeah, so this is all good to go. Discovery address, discovery port is going to match the same one in use on these other two apps. And so once I start this running, we can see the system showing up. So what's happening is it's getting the discovery information the same as these two apps are. So that gets it all the way down to the node level. Then the next thing it does is once it knows about the existence of the node, is these guys are running HTTP servers. And let me go ahead and pull up a web browser. We're going to go with localhost slash config slash publish. So I'll get this queued up. So we've got this endpoint that is running in these applications. Why can I not drag? Where's the corner drag? There it is. Thank you. And once it has the uh, the auto discovered services that are available on a node, it can use that to build the URL. Config publishes a standard endpoint that is run in Vecto. So if we do that, we can see we get some more information for that node. So we already know what the node is, presumably, if we've kept our data mapped correctly. But what we don't know is what groups of data are being published from that system. So we can then get some JSON that lists the groups and get the group name, get the publish information for that group. So this test data group from the alpha node is going to get published on this multicast address. And again, multicast addresses can get shared between multiple nodes and multiple data groups. And then the other thing we want to know is what are the channel names. Publishing the data is just the group name and the values. Optionally, the raw data values. So if you want to send both raw data and scaled data, you can. Um, and data timestamp. But it doesn't send the channel name every time because that could take could take a significant chunk of bandwidth increases when excuse me, all we need to know is this list once. And then just for some internal application organization, what's kind of the internal module or task that is responsible for generating that group data. So once this telemetry debug tooling um, sees a new node, it's keeping track of a map of nodes it's seen, and we'll see if config changes or anything like that. It will then generate that HTTP request to get the rest of this information, then set up the internal uh, group inside the telemetry debug instance, and it's supposed to be subscribing to these data updates, but for some reason it is not getting those at the moment. So I got to finish digging into those, and for some reason I can't tell why the beta group is not getting its stuff listed. So I should be able to go to that same exact URL, but on the other port that I told it to open, and we can see it's returning the same information. It's the same application with the same programmatic config generation. So that makes sense. But that is reading. So a couple of things to work out, but just wanted to demonstrate some of the debug tooling that I'm starting to get going and uh, talk about some more of the mechanisms that are under the hood.